Hey, today we're going to show just some more dilation stuff. I do have this image which could be helpful to reference with the different transformations. We have the isometries and the non-isometries. We're going to continue to be focusing on dilations today, which means that in order to perform the dilation, you multiply the x and the y coordinate by whatever the scale factor is. I'm just going to briefly explain this page because there's not really anything new on it. Basically, they're going to be asking like two different types of things over and over. One thing they might be asking you to do is to identify the type of dilation. When they ask you what type of dilation it is, they're asking for a reduction. So is it a reduction or is it an enlargement? That's all they mean by the type. And then in other types of questions, they might also ask you to find the scale factor. And we've done that before. That's basically saying, find K. So find whatever it is that you'd be multiplying the first set of coordinates by in order to get the second set of coordinates. So yeah, I'm going to leave that page for you to do, and I'm going to focus more on a different page, which has some really challenging problems on it. So looking at this page, problems 3 and 6 are totally normal. You don't need me for that. It's exactly what we've been doing already. What I want to focus on are problems 4 and 7. So 3 and 6 you're going to do, but do them without me. 4 and 7 I want to go over because they're really challenging extension problems. This is one of the more difficult transformations. And like I said, it's an extension problem. So if you can't do it, you can't do it. But I think it's worth showing it to you. We've talked about how dilations are basically an explosion from the origin. So if you have some shape centered around the origin and you stretch it or you shrink it, it kind of stays with the origin in the middle of it. And that makes the dilation easier to perform because you can use the rules of multiplying x and y by the same number. This problem changes the center of the explosion to a different point. So I'm going to show you a strategy for doing this, and you'll just do your best. Start by graphing the original points, please. So you can always pause the video as I talk if you need more time. Go ahead and graph the original points. Alright, so hopefully that was enough time for you to do it along with me. So these are my original points. And now if the center of my dilation was the origin, which it usually is, we would use the scale factor of 2 and we'd multiply all these numbers by 2. But they've changed the center of the explosion here. So now I'm going to put a star where the explosion's happening. It's at 1, 2. So right here. The way to do a dilation, if it's not coming from the origin, is to look at how each of these points is spaced away from the explosion and use the scale factor of 2 from there. So I'm going to start with A and T because those are a little bit easier to see. Right now, A is 2 points away from the center of the explosion, from the star. The scale factor is 2. How far away from the star do you think it'll be after I explode it? If you said 4, you're correct. So instead of being 2 spaces away, it's going to be 4 spaces away. So let's see. A prime is going to be down here because instead of being 2 away from the star, it's 4 away from the star. So A prime is going to end up being at 1, -2. See if you could do T now. Pause the video for more time. So originally T was 2 away from the star in that direction. But at the scale factor of 2 tells me it has to be twice as far away from the star. So it's going to be 4 away from the star instead. So T prime will be here. And that's at point -3, 2. The last one is H, which is harder because it's not in a straight line away from the star. So what I'm going to do is think about like a vertical and a horizontal distance. To get from the star to H, oh, this 2 can go away. To get from the star to H, I'm going to go 3 down, 2 left. So the relationship is 3 down, 2 left. I need that whole relationship to double because the scale factor is 2. So I could multiply these by 2 and say now I need to go 6 down and 4 left. So from the star, 6 down would be 1, 2, 3, 4, 5, 6. And 4 left would be 1, 2, 3, 4. So H prime is going to end up there. Get rid of all that. So H prime ends up at -3, -4. And if I connect it, you can kind of see how the explosion does look like it's coming from the star now. Everything is twice as far away from the star as it was before. If that didn't make total sense to you, that's all right. It is an extension. It's okay. But I wanted to show it to you. What I'd like you to do next is to try number 7, which is similar, except this time it's a reduction instead of an enlargement. Do the best you can, try it, and then come back when you're ready for me to show it. Okay, so I'm starting the same way. I'm going to plot my original points. So I is at 1, -2. B is at 1, 4. And B is at 4, 1. So here's my original guy. All right. Now I need my star. My star is going to be at -2, 1. So everything is exploding in towards the star because the scale factor is 1/3. I'm going to start with M because M is the only one on a straight line. So the original distance from the star to M is 1, 2, 3, 4, 5, 6. So instead of 6, I want it to be 2 because 6 times the scale factor of 1/3 is 2. So that means M prime is going to be right there. So that's 0, 1. Let's see, I want to count one more time. 1, 2, 3, 4, 5, 6. 6 divided by 3 is 2. Okay. I was doubting myself. So now I'm going to do the same thing for B. So B is 3 to the right, 3 up. 3 right, 3 up. So from there, I want to multiply both of those by 1/3, and that's the same thing as dividing it by 3. So it becomes 1 right, 1 up. All right, so 1 right, 1 up is going to be there. So there's my B prime. And then same thing with I. So originally from the star, I is 3 right, and then 1, 2, 3 down. So 3 right, 3 down. And instead, I want it to be 1 right and 1 down because I'm dividing them both by 3. All right, so 1 right and 1 down puts me there. Oh, and I forgot to be recording it here. So I is at -1, 0, and B is at -1, 2. And then when I connect them, I can see it does look like the original shape, and it looks like it's exploding inwards towards the star. So I hope getting to see that, you learned something from that. If you didn't totally understand it, that's all right. Please make sure you guys finish up the assignment. Thank you guys for